we want to summarize what we mean by a slope graph. Naturally, all these topics are covered in more detail. The object here is to give you kind of a quick reminder of what we mean. Okay, so I'm not going to be rigorous about the definitions, and not necessarily, but this is pretty much a rigorous definition. Okay, first, so a slope graph means a graph of the slope of the tangent line versus the x-coordinate of the point of tangency. Now, what do we mean by that? Big old sentence. It just means that we can take, let's say, a few points in this graph. Usually we would use more than 3, but I don't want to take a lot of time here. And we can construct a tangent line at each of these points. Now, I'm not constructing the tangent line, I'm just sketching them. Now, what we want to do to easily and quickly construct the slope graph is we want to take 2 points on each tangent line. Okay, let's take these 2 points on this tangent line. Then the slope is going to be the rise divided by the run. And then we do the same for the second tangent line if we can locate the thing. Let's just use a different color. So for the second tangent line, we have a point here, let's say, and a point here. Well, I want these points, I want to use points whose, I want to use points such that the run of the triangle I get between the 2 points is always the same. So, the run is this, the run is this, the run up here needs to be this, which means that my second point would be here, let's say, if the first point is here. Okay, so now I've got 3 triangles that we can use to represent the slopes of the 3 lines, and in fact, since we have the same run and slope is rise divided by run, I can just use the rises of these 3 points to represent the slopes. Remember, these graphs are unlabeled, so let's say here's the x-coordinate of this point of tangency. That's what we mean by the x-coordinate of the point of tangency. Here's the other next point of tangency, and here's its x-coordinate. And I've also sketched the x-coordinate in this graph here that's going to be my slope graph. Okay, here is the x-coordinate of this point of tangency, and we can come straight down and get the x-coordinate here. So now, instead of calculating a slope and using numbers, I can just use the rises to represent the slopes. Since the rises will have the same relative values as will the slopes, this is perfectly legitimate. So I use this rise for this x-coordinate, and I obtain a point here. And then I use this rise, associating it with the point of tangency, the x-coordinate of the point of tangency. Bring it down here, and I've got this coordinate. Then I use this rise, associating it with the x-coordinate of the point of tangency, and I've got this point. Now, it's not clear whether this is a power function or an exponential function or what, but if it is a power function, then it probably has a graph that looks something like this. Now, if it's an exponential function, then it probably goes through the x-axis, so maybe it looks like this. You can't tell just by looking at it. But we can test this function to see if it is a power function. We test this function to see if it's a power function. I don't know if I can sketch a graph of a power function here. So let's see. How do we test this to see if it's a power function? How do we test this to see if it's a power function? Or maybe this is some kind of an exponential function down here. How do we test to see if maybe this is an exponential function? Well, we'll talk about those tests in a minute. But now the question is, what's the relationship between the slope graph in the original graph. And recall that we used the prime symbol. So if this is y versus x, we're going to say this is y prime versus x, and y prime is going to be f prime of x. The prime represents the slope of the graph of y, and f prime represents the slopes of the graph of f of x. So that's what we mean by slope graphs. These slope graphs have very important properties.